All right, so we're going to play around with sets, something similar to C, but not exactly the same because I don't want to spoil your fun. And it's a tough one, but once you figure it out, it's easy to check that you're right. So playing with set intersections is what we're doing here. And my advice on those problems, set intersections, is to solve a couple of them and then decide which is your best solution and submit that one. So we have 3 sets, 1, 2, 3, and let's think up another scenario instead of scholarships. Maybe it is sports. So we have, let's see, what's a sport that starts with an A? Aerobics? No. Archery, there we go. So we have archery is one of these sports, and then let's say baseball. My dad loved baseball. And C is for cricket? No, cross country. All right, so we have A, B, and C. And we'll do, there's 3 people that play all of them. Let's see, archery and basketball. No, that's archery and baseball. You know, you're throwing and aiming there. I bet there's a bunch of people who do both of those. So maybe there's like, let's say 12 more for a total of 15 who play archery and baseball. Archery and what was the C? Cross country. Yeah, I guess you could run and shoot a bow, but maybe that's not quite as popular. So we'll put 6 more there. And then baseball and cross country. Yeah, you know, you gotta run those bases. So that might be pretty popular. So maybe we'll put 9 there. But then there's just a bunch of people who like baseball and not much else. So maybe we have 15 there, and over here, archery, you know, not wildly popular in Rhode Island, more popular around here, I would think, from what I know, my friends around here. And then C's cross country, not as popular as baseball. Maybe there's 7 over there. So with this filled out the way it is, I just want to remind you of how this breakdown works. And let's say everybody plays a sport, right? We have nobody outside of that. So the total number of people in my universe, assuming there's nobody, like everybody in this universe plays either archery or baseball or cross country, what do we've got? We've got 2, 14, 29, 38, 41, 47, 54, if I did that right. So the number of things in the universe appears to be, I think it was 54. We'll double check that in a minute. And if anybody has a count on that, let me know. If we just looked at the number of people who played archery, that would be the sum of these 4 numbers. So 2, 14, 15, 16, 17, and 6 is 23. There's 23 people who play archery. Baseball, we've got 15, 27, 36, 39 that play baseball. So number of people who play baseball, 39. And then the number of people who do cross country is what? 13 and 3, 16, and 9 is 25. And again, some of these 23 also play baseball. They also play cross country. Some of them even play all 3, right? Other things like the number of people who play archery and baseball, that would be the 12 and the 3. So that would be 15 here. So just getting used to how all these sets work. The number of people who do archery or baseball, the union is our or. So let's just add some more text here. This one here is and, this one here is or. And stop me if you have a question, or please ask in the chat or through your mic. Let's see, that would be these 2 circles combined without overlap. So let's see, 12 and 3 is 15, and another 15 is 39. 45, 6, 7. That looks like 47. To double check that 47 right there, let's do a double check. That would be all of the people who do archery, that's 23. And all the people who do baseball, that's 39. But when we count the 23 and the 39, we've double counted. We've double counted these 15 right there. And so we would then have to subtract 15. And so let's see, 23 and 39 is 50, 62, 62 minus 15. Yeah, that's 47. That does check. So I told you we would go back and double check some figures. We'll come back to the 54 soon. So other things I could answer here are so like one of the questions was, if we look back, so again, we're trying to piece together something like this by working backwards. And again, I did pick different numbers on purpose because I can't do this one for you. 2 received scholarships in all 3 subjects. How many received scholarships in exactly 2 of the 3 subjects? So let's think about what that means in the picture. Exactly 2. So people that play exactly 2 sports. Exactly 2. What does that look like? And just a reminder, I was saying A is archery, B is baseball. Everybody has to play something in this group, and C was cross country. So that would be, for example, that 12 right there, that would be the number who do archery and baseball and not cross country. And we can either do a not by putting a line over it, or let's see, what was our other symbol for it? I think it was a little tilde by it. So just a reminder, that bar over the top means not cross country there. And that's what that 12 represents. If we wanted to identify, say, this 6 right here, switch colors, so let's relabel the 12 red. That's this measurement down here. Switch to blue and do that 6 right there. That would be the number of people who do archery and cross country. That was a lousy and. Should be a U shape. It's called a cap, whereas this one is the face up one is called a cup. So this is our intersection symbol. So archery and cross country and not basketball. So we put a bar over the B to say not that. That would be that 6 there. And then I guess we'll switch back to green for this 9 here. That would be the number who do, oops, A for arch. No, not archery, that one. That one is basketball and cross country mainly. Basketball and intersect cross country and not archery. And that would be that 9 right there. So then we're going to try to rewrite that problem based on what we have here. So, steal part of this picture. Just wanted this part here. And then some of those numbers. So let's add that to a new page. Not too bad. Move it over. All right, so then we're just going to try and write a similar question to this one here. So we have the total number in one, the total number in the other, the total number in the third one, how many they were all together, and then how many received all 3 would be the given information. All right, so we believe that there were 54 altogether. And so rewriting this in 10. So let's see, there are, what was that one? 23. 23 people who play or practice archery. And 39 play basketball. Oh, baseball, sorry, Dad. Baseball. And what's the other number? For cross country, we ended up with 25. 25 who do cross country. There are 54 people total. And we have 3 that play all 3 sports. 3 people, clear about that, play all 3 sports. And then without knowing all of this information here, we want to know how many play exactly 2 sports. Question mark. So I'm just going to erase some stuff. Oops, my eraser doesn't work on that, really. Oh, interesting. Because it's a picture, it's not a copy. Oh, that's cool. Sorta. Not what I wanted. All right, so we're just going to delete it and start over. Fun with technology. All right, so let's redraw our universe. And our 3 circles. All right, so we know that the number of people in the universe, that was given to be 54. And then here's our archery, our baseball, and our cross country. So I'm just going to make a little note that the total number of people for archery, I'm just going to put a little 23 above it. And those 23 have to live, all of them, inside this circle. All right. And then there's 39, we'll do that one in blue, that do baseball. And right, that's all the people that live inside this circle, but we got to make believe we don't know where they live yet. We're going to try and play around and guess. And then 25 do cross country, and we'll just stick with green on that. So there's 25 there. What we do know for sure is that there's 3 in the middle, right? So we have that fact that there's 3 right there. When we add numbers up, like if we try to take the 23 plus the 39 plus the 25, so just kind of messing around, if I take the number of people who do archery and add that to the number of people who do baseball and add that to the number of people who do cross country, that would be 23 plus 39 plus 25. Let's see, what does that add up to? 20 and 30 is 50, 60, 70, 75, and 9 is 84, and 3 is 87. So this adds up to 87. We know it should be 54, right? So we've done a whole bunch of double counting. So let's try and figure out that double counting thing. Well, we've double counted this area right here. So we would have to take that out. So to get that back down to the correct number, 54, we'd have to remove the double count we did on A intersect B. Because that got counted twice, all those guys right there in that crescent. And then we're also double counting A and C, right? Everything that was in this crescent. And we know that was 3 plus some more, but we don't know that more at the moment. We're making believe we don't. So we also have to remove that double count because the archery people counted that crescent. So again, if it's not clear what I'm saying, all the people in this region were double counted. So that 3 was counted twice plus whatever's there. This region here was double counted. That 3 was counted again, plus however many here was counted again. So switch back to the pen. And so that's that A intersects C was double counted. And then this region here was double counted too. So let's take that away. Number of, now that would be B intersects C. Oops. Well, now when we remove those, we removed that 3 right there 1, 2, 3 times. So we took it away 3 times. So that means we took it away too many times and we got to put it back in. So what is that 3? That 3, let's use blue, that would be the number that do archery and do baseball and do cross country. And let's make sure we got this count right here. All 3 of those counted that. So that 3, let's see, it got counted, let's use a highlighter to figure this out. That 3 got counted here. Oops, that's not a highlighter. Again. Is that the highlighter? Yeah, okay, so that 3 right there first got counted here, here, and here, but then we took it away there, there, and there. So it got put in 3 times, then taken out 3 times. So that means that 3 is not unaccounted for unless I put it back in. All right. So let's play around with the numbers we know on the other page to try and figure out if we're getting on the right track here. So back here. Those intersections, let's see, I wrote one of them down here. That was 15, and the 15 is this group right here. So going back here, we know, because we're solving this backwards, that there were 15, oops, wrong color, red, there were 15 in A intersect B, right, this group here. Back again. AC, there were 6 and 3 or 9 in there. And then B and C would be down here, 9 and 3 is 12. And we also know by looking at the picture that the 3 appeared here, here, and here, then it got taken away 1, 2, 3 times, so we got to put the 3 back in. And let's see how this works out, how our accounting is. So that gives us 87 minus 15 minus 9 minus 12. So let's just condense these 3 right here. 15 minus 9 is what, 24, minus another 12 is 36. So if we take away 36 from 87 and then add the 3 back in, so what does that give us? In between here, that would give us 51 plus that 3 right there gives us the 54 total that we want. Sorry, I got a little messy there. Oops. 54. All right. So this is the way the original set's numbers, the intersections of 2 sets and the intersection of 3 sets are related. The intersection of 2 sets, those red numbers here, right? Those are these crescent shapes here. Those green crescent shapes I did with the highlighter. And that intersection of all 3 is that cute little trifold thing in the middle there. All right, so now that we have some kind of relationship about how the total 87 and some of the intersections are related to get the actual total number of participants, we want to try to answer how many play exactly 2 sports. Well, the exactly 2 would be the number here, here, and here. Right? And that is certainly related to each of these, but without the 3 each time. So let's see, how do our numbers work out there? Let's go back here. That would be the 12, the 6, and the 9. These three numbers there. And if we add those three, that one, and that one, and that one all together gives us, let's see, 12 and 9 is 21, and 6 is 27. 27 compared to the 36 there. And then the 3 had something to do with that, the 54, the 87. So we got to find a relationship between all of those. Let's see. What can we say there? And again, we got to keep in mind what's known. So maybe we should highlight the known information. I guess the known information here is green and blue. The red stuff I backfilled, solving this in reverse. So these numbers all here are known. The 54 was known. The 3 was known according to the original question, right? This is what I know right here. And this stuff in red was unknown according to the original question. Okay, I think I need another piece of paper to scribble on. I ran out of room here. If anyone sees the solution before me, let me know. I can scribble up here a little bit. Let's use red for messing around. So we know we've got the 23, 39, and 25, and that's an 87. And that overcounts a whole bunch. In particular, it counts that 3 many times. 3 times. Because that belongs to archery, baseball, and cross country. And those 3 play 3 sports, not exactly 2, so we definitely don't want them. So we definitely have to take those 3 away because they're not part of the answer I want right here. So 87 minus 3 is 84. Okay, next thing to consider. So those 3 are out of the 87. But we know the 87 counted stuff too many times. It counted the 3, 1, 2, 3 times. So we don't want to just take out the 3. We want to take out 3 3 times because it was counted 3 times. Let's try that again. We want 87 minus 9 because 9 is 3 times 3. That 3 was counted by all 3. Okay, so 87 minus 9 is what, 78? Okay. And then those 78, there's a bunch of double counting going on. I want to say subtract the 54, but that doesn't make sense that subtraction is meaningful, but I'm not sure it answers this question. So what will that give us? That will give us 8 minus 4 is 4. And 7 minus 5 is 2. That gives us 24. We know the answer is 27, but why would just adding 3 work there? Oh, I think I see it. All right, I'm gonna write this on a new page. Okay, so we just put together a formula that says the number that do archery or baseball or cross country, that's our 54. I get that right? Yeah, the union of all 3 of them is 54, right? The total number of students in those 3 circles there. We know that that's equal to the number of people who do archery plus the number of people who do baseball plus the number of people who do cross country, right? That formula we get on the other page. But that double counts, so we got to remind ourselves that, yeah, but we double counted archery and baseball. We double counted archery and cross country, and we double counted on baseball and cross country. Those were those crescent shapes. Baseball and cross country. But we've taken out the intersection of all 3 times. We put it in 3 times. We got to put it back in, and we decided we had to do plus A intersect B intersect C. All right, so putting our numbers back in from our fake example, that was, let's see, what? 15, 9, 12, 23, 39, 25, 23, 39, 25, and then, oh, wrong button, 15, 9, 12, and 3. Plus 3. Other things to think about is this A intersect B here. That's the people who played 2 or 3 sports, because the A intersect B doesn't say whether they played cross country or not. And if we look back to our original picture, that 15 right there is both the 12 who played only archery and baseball plus the 3 that played archery, baseball, and cross country. So this right here, I'm just gonna say that 15 is really some number plus 3, and I want that number right there for the archery and baseball people that don't play cross country also. This 9 right here is some special number plus that 3 also. I don't care about those 3, I want the other ones. Now, we don't know what the 15, 9, and 12 are in our original problem though. And then the 12 would be some missing number plus that 3 again. And it's these 3 numbers right there that are the people who play exactly 2. And 2 sports in my example, but the problem you were asked was about scholarships. So when I'm trying to figure out those 3 numbers right there, and again, those guys were subtracted order of operation wise, they need parentheses. And that's a circle, not a 0 there, by the way. It's just kind of a variable placeholder for using a circle, triangle, and square as my missing numbers. So I'm taking away that 3 again and again and again, and then putting it back in once there. So if we look back here, when I was playing around with these numbers, I took the 3 away 3 times, but I needed to put it back in once, which is kind of what this says right here. Take the 3 away 3 times, but put it back in once. And these numbers right here, that was that 87. Yeah, that makes sense now, how that works. So it looks like from the actual total, we take away the overlap total here. We can call that, because that's a whole bunch of double and triple counting. And then we just have to take the 3 away a couple of times because these 2 balance each other out there. So if I take that 87 minus the 54, and then I only take away 2 of these 3's because these 2 cancel each other out. So minus 9, what does that give us? 54, I guess I could do 87 minus 54 is what? 33, and then we take away 9 from that. That gives, or did I make a mistake there? I think I made a mistake here somewhere. 87 minus 54, 4 minus 7, 7 minus 4 is 3, 8 minus 5 is also 3, okay. And then that's, oh, that's gonna be 24. Oh, 9, 3 plus 3 is 6. I only wanted to take away 6 there. And then, yeah, that'll give me the 27 that I knew should have been the answer for only 2. Okay. Wow, that was a tough problem. And I don't know if you remember, one of the problem solving strategies we went over way back in section 1.1 was to try and solve the problem in reverse. And one way to do that is to make up a similar problem knowing the answer and then try and backfill a solution that gets back to the answer that we want. All right, so man, that was tough. So I would need to do that a couple more times to convince myself that was really true with made up numbers to see that this system here actually works. And I couldn't do it without a Venn diagram.